We fantasize about finding far-off universes spilling over with rich vegetation and life very much like here on Earth. The James Webb Space Telescope has now found a genuine climate on a far-off super-Earth. Interestingly, we could be well on our way to finally exploring a world like our own in the depths of space. However, 55 Cancri E presents specialists with a riddle. The exoplanet, which is only 41 light-years from Earth, sometimes appears as a super-Earth and sometimes as a rough heater. But which is valid? The James Webb Telescope has made several surprising discoveries in the search for answers to these inquiries. Analysts are utilizing NASA's new JWST to finally investigate the Earth-like planet 55 Cancri E with the help of this heavy technology. This exoplanet is an immediate neighbor of Earth on a grandiose scale. This world has dumbfounded specialists on numerous occasions since its discovery in 2011. Initially, the planet appeared to be a hot but rough world that might have an atmosphere. However, researchers found stunning new data about this planet using Webb's remarkable methods of investigation. Scientists had to unravel the mystery surrounding this strange planet, and they succeeded. The results are astounding. The study's director, Renu Hugh from NASA's Jet Propulsion Laboratory, was excited with the James Webb Telescope, stating, "We are now entering a totally new aspect of science. For the first time, we know exactly what is happening near the exoplanets, and we might get our initial insights into the planet's surface. Is 55 Cancri very hot, or is it a super-Earth? You might think it is extremely hot, and that is totally right because, ordinarily, only planets that offer far better living conditions than our own are called super-Earths. Generally, such planets are somewhat larger, somewhat denser, a bit hotter, and their stars have a longer lifespan than our Sun. The first 2 points apply to 55 Cancri. For a long time, we knew the size of the planet, its orbit, and its approximate density. However, we had no substantial data on an atmosphere, and the temperatures were just estimates. Never before in the history of space science have we been able to concentrate on planets outside our solar system with such accuracy and detail. Webb spectrometers can not only identify water in a planet's atmosphere, but also gases like methane, carbon dioxide, and other volatile compounds. The more similar the investigation data of the planet's atmosphere is to the values of our Earth, the more certain we are that we have found a genuine super-Earth. 55 Cancri E is one of 5 known Earth-like planets, circling the Sun-like star 55 Cancri, with a diameter twice that of Earth and a higher density. The planet was previously designated a super-Earth. Earlier investigations of 55 Cancri E yielded oddly problematic data. For instance, studies by the Spitzer Space Telescope showed that the planet orbits its star so closely that its surface is probably less rocky and more molten. Besides, the planet's orbit is probably tidally locked, resulting in a day side and a night side. This so-called super-Earth could be a burning hotspot that neither harbors an atmosphere nor can support life. Specialists have repeatedly taken on this abnormal world. Experts from the University of New Mexico have now studied 55 Cancri E seriously for over 10 years. The researchers described it as outright disappointing that none of the observations had thus far yielded clear results. The new telescope should finally shed light on the darkness and reveal the mysteries of this planet. Does 55 Cancri E have 2 atmospheres? Is it possible for a planet to have 2 atmospheres? Yes, 55 Cancri E once had an atmosphere that was then stripped away by its star. It's almost staggering since this variable planet essentially developed another atmosphere. The spectroscopic examination amazed researchers. They had never had such detailed and extensive data on this planet prior to utilizing the latest information. The analysts were able to accurately reconstruct the history of 55 Cancri E's atmosphere, and it is truly unusual due to its extreme proximity to its star. Surface temperatures of around 2,400 degrees Celsius have literally incinerated the protective shell. However, this exoplanet performed a miracle and replaced its original atmosphere of hydrogen and helium with a new one. This secondary atmosphere was formed in a remarkable way by outgassing from the rocky interior of the planet. It was probably the high temperatures at 55 Cancri E that caused a new atmosphere to form. However, the new atmosphere is very different and consists mostly of carbon dioxide and carbon monoxide. Webb's generally precise spectrometer examination. You can't help thinking about how the JWST can recognize such subtleties. The light that contacts us from 55 Cancri E is little to the point that Webb would never take an immediate picture of this planet. Anyway, the telescope can measure minute changes in the framework's light as the planet circles the star. The information from the MIRI instrument shows the 55 Cancri system's brilliance diminishing as the rough planet 55 Cancri E moves behind its star. Researchers allude to this peculiarity as an optional obscuration, and the pictures of the examination chart show an optional obscuration light bend during an optional overshadowing. The light reflected or radiated by the planet is darkened, so that only the light from the star is estimated by contrasting the brilliance previously and during the obscuration. The sum of light coming from the planet can be detached and broken down. The information shows a clear drop in brilliance brought about by the planet's emanations. But centric is of these emanations revealed that the temperature on the day side of the planet is about 1,540 degrees Celsius, which is a lot lower than expected and demonstrates an unstable, rich climate that appropriates energy from the day side to the evening side. Totally insane life on 55 Cancri. It sounds insane, but past information from NASA's currently dead Spitzer Space Telescope over and over demonstrated the presence of an environment with indications of oxygen, nitrogen, and carbon dioxide. These could be biomarkers and proof of life. In any case, how might it be that a planet with such outrageous surface temperatures shows hints of biomarkers in its air? Planetary scientist Hugh explained in his article in the journal Nature that 55 Cancri even showed marks of metallic substances and components, for example, silicon, iron, aluminum, and calcium. Anyway, the temperatures are so high that researchers suspect that the source of these follows could be a slight cover of disintegrated rock. This raises the interesting question of whether this planet was once cooler and had new natural cycles. We know from our own nearby planet group that planets have traded positions inside the framework throughout millions of years. It's conceivable that the rough world 55 Cancri E was once in a tenable zone and just later moved into a circle that carried it nearer to its star and the overwhelming temperatures. Our Mercury is likewise being pushed endlessly further towards the Sun by Jupiter, and some specialists expect that Mercury was once in a circle further away from the Sun. Then, at that point, it may be the case that there was once life on 55 Cancri. The exoplanet shows up increasingly more like a universe of obvious contrast and a world that has gone through fierce changes. This is shown not just by the bound circle, but most importantly by the problematic estimation results from the different telescopes. The first sign of an impressive climate came from temperature estimations based on the warm outflows of this world. If the exoplanet is truly covered by dull liquid stone and a slight shroud of disintegrated rock, the day side ought to be around 2,200 degrees Celsius. Hot Webb's MIRI information, however, showed a temperature of just 1,540 degrees Celsius. This might be because of the way that the energy is all around conveyed by warm processes between the cool night side and the hot day side. Magma streams move intensity to the night side, where it is circled and cooled. In any case, reproduction showed that this impact alone isn't adequate to make sense of the much lower temperature. When the examination group inspected further information from networks close to CAM, examples of an unpredictable but rich environment were again uncovered. This does not fit with a planet made of disintegrated rock. The group, led by planetary researcher Hugh, has reached a resolution that 55 Cancri E has some unique component that should have something to do with the break of gases from its inside. Thanks to Webb, examination into this astonishing planet has made considerable progress, but is still a long way from complete. Genuine hints of life in space, Are you captivated by such weighty discoveries as those about 55 Cancri, or are you one of those individuals who might be substantially more thankful if we could at long last demonstrate the presence of genuine extraterrestrial life in space? Even on the off chance that we have not yet prevailed in giving conclusive verification, the James Webb Space Telescope has carried us closer to this objective than any time in recent memory. Additionally, with a remarkable reach and sharpness, the JWST offers us the open door to investigate exoplanets for the first time. Albeit a portion of these planets are gigantic, they are small items contrasted with the elements of the whole universe. For quite a long time, following them down was like searching for a needle in an impractically limitless feed stack. We currently know about more than 5,000 exoplanets. That is a ton for our science. However, estimated against the real number of planets, it's not so much as a small bunch. The specific number of Earth-like planets is continually changing. Up to this point, we have 2 or 3 dozen up-and-comers that have the stuff to be Earth-like. The JWST is now tasked with explaining which planets are truly Earth-like and which are not. Proxima Centauri b has frequently been named as the most Earth-like planet. This planet, which is just 4 light years away, circles the star nearest to us and lies in the livable zone, where the circumstances for fluid water are great. Our expectations of tracking down life there blurred after the star Proxima Centauri coordinated Savage flares at its planet. After this failure, consideration went to other significant competitors, for example, Kepler 452b and TRAPPIST-1e. Webb had the option to affirm the presence of the Earth-like planets in the TRAPPIST framework, but the Person examinations are still deficient with regards to the star. TRAPPIST-1 probably has 7 planets around it, 5 of which are like our Earth. Kepler 452b is currently the most Earth-like planet at any point found in space. It is around 6 billion years old and marginally bigger than our home planet. Here, too, we as of now know nothing about a climate or indications of biomarkers in the climate. We will need to hold on until the JWST examines this world exhaustively. Click subscribe at this point and anticipate many new thrilling recordings.